Hey, welcome back to the second video on rational equations. So this is the question now that is different from part one. Why? I have now two rational expressions equated. However, we know when we did a similar example, when the left-hand side was equal to a statement similar to this, the right-hand side one was constant number, so we did cross multiply. So why can't we do this approach here again? So we'll do it. We'll do this one more time. Now, restrictions. As from the previous video, you set the bottom equal to 0 here. Okay. And you also set this bottom expression to 0. They both would have -2, and the left-hand side would also have 1. So this is why -2 and 1 restricted values. So no way your root could be possibly equal to that. So first we'll do factor, and the factoring helps a lot with restrictions. So this is why you see the restricted values -2 and 1, and we'll do in two different ways and solve that equation. So first, cross multiply. So we know that strategy from part 1 video. We simply did the following approach. Multiply this times that equals to this top times that denominator. So this is what you see here. Okay. The next step would be to, if you want to expand it, then you create all kinds of problems because you would get cubic equations. It would be messy. It would be possible, but I would rather focus your attention on the fact that we have common factors. We have x plus 1. It's not a common factor. Okay. Select another one. We have x plus 2 here, x plus 2, 2x plus 1 on that side, and 2x minus 1. I said 2x minus 1. So we can take advantage of that and take out these two factors from these two sides. So let's do it. So this is why you see 2x minus 1 and x plus 1, x plus 2, I'm sorry, x plus 2 is a common factor. So from up above, we take x plus 2 as a common factor and 2x minus 1 right here. And what you have left, from the left side you have x plus 1. From the opposite side you have negative x minus 1 because you moved it over to the opposite side. Everything is equal to 0. Beautiful. Let's clean up the mess inside of the bracket. So by distributing, first you have negative x and plus 1, and further down you expect to see just that. So common factor, 2x minus 1, x minus 2, this becomes a constant value. So now solve it for x. So the product is equal to 0 when 2x minus 1 is 0 or x plus 2 is 0. So 2x minus 1 gives me 1 right here. Beautiful solution, 1 over 2. The second solution from here would be -2. But you know that -2 is not part of your solution, so this is why you reject that. Important. We may get solutions down the road, but always examine your roots against the restrictions. Key, important for us to remember. So cross multiplication is done. Let's solve this by using common denominator. Okay, so the new denominator here that is common for both, I have a factor x minus 1 and x plus 2. I have x plus 2, then naturally the next step is to multiply the right hand side by x minus 1 over x minus 1. Boom. When I have a common denominator and I have left side equal to the right side, I have a freedom of dropping the denominator. This is simply if a over, I can't use that to change the pen. This is the idea, a over b is equal to c over b. This implies that numerators are to be equal. So this is why I can drop the denominator and work with the numerator. So this is why you have top from the left side is equal to the top value from the right hand side. The next step is obviously not to multiply it. You could multiply it out and then bring everything to one side, work with quadratic equation, or my option here is to take out the common factor to x minus 1 and x plus 1. So keep this entire thing on the left hand side. When you take out these two brackets, you have, no, sorry, let's go back. 2x minus 1 is the common factor. This and that only is a common factor. So that goes out. So I have right here, and in goes x plus 1 minus x minus 1, because positive sign in front. When you move it to the opposite side, you would have negative x minus 1. Simplify. So now you have 2, factor 2 from that portion to x minus 1 is what was already there, and you have the solution x is equal to 1 over 2, and this is exactly the same as using this, right? So whether you use common denominator or you use cross multiplication approach, you will get the same result. The key here is to remember, if I have more roots, each single root that I have to examine with my restrictions. That's the bottom line. So now you should be able to solve any rational equations. It doesn't matter whether you have two rational equations of both sides, or you have this equal to 0, or the value on the right hand side is 3, or anything. You know that you can solve it now. There is one thing that I want to bring your attention to, is what not to do in case I have a different idea of finding the solution to this equation. So let's look at this. Avoid steps like that. Supposedly you did your factoring on both sides, and you said, now since I have the same factors on both sides, why don't I eliminate? Why don't I divide both sides by 2x minus 1? Let's say you did that and you have this nice step, cross multiply, and you have no solutions, but you do know that there is a solution to this question because we just did this question. So how come this method does not show me any roots? This is not because we did divide both sides by x plus 2 or multiply, because this has no zero value since x cannot be equal to negative 2. Remember the restrictions? So this is not the problem with the green portion of that. The problem is when you decide to divide both sides by a value that could be potentially equal to 0. So this is why we went into this step that shows no solutions. So this is very, very important. I want you to pay attention to that and recall the rules from polynomial equations that we discussed, part 1 video, that you can divide or multiply both sides of the equation by non-zero value. And that has to be very, very emphasized, non-zero value. If you choose to divide it by something that could potentially be 0, problems. So avoid steps like that, Always be mindful of rules when working with equations. Thank you very much for watching this video, and I hope you have enjoyed it. Post any questions right below. Go right below this video and say, this is what I didn't like it, or whatever questions you have. And I see you next time. Bye for now.